And moving on to lesson 5, we're going to look at some more theorems about lines and planes. And some of these you'll just read on your own. There's no need for me to go into them or spend much detailed time on them. But let me define a couple of things. The first thing is uh, a few different types of lines, and then I'll show it with the example of a cube. Perpendicular lines are lines that intersect and form a 90-degree angle. When they form a 90-degree angle, they are, or a right angle, they are perpendicular lines. This is the symbol for perpendicular. So if I say perpendicular, I might be using this as the symbol. Next set of lines is parallel lines. Parallel lines, and this is the symbol, looks like train tracks. I always think of these as the two L's in parallel. But parallel lines are two lines that will never intersect. So they are, so no matter how long or how far they go, they do not intersect. Skew lines are lines that do not intersect, but are not in the same plane. Now this one, I'll just have to define it using this cube. Let's go ahead and identify a pair of perpendicular lines. Well, this is a cube, so all angles are right angles everywhere you look, because I drew a perfect cube. So for example, AE, lines AE and EH are perpendicular. AE and EH, when they meet, they form a right angle. Example of parallel lines. DH, line DH, and CG are parallel. These two lines, they're in the same plane. Notice they're the perimeter of this box here, but they're in the same plane. They will never intersect. An example of a skew line. So first we have to look at at separate planes. So I'll look at AD, line AD. There's no symbol for skew that I know of. But line AD is skew with, for example, BF. BF. Now, it may look like it could be a right angle, but this is not on the same plane. So therefore, AD and BF are skew lines. So you can find different ones there. And then the last thing we'll look at here is parallel planes. It's the same thing as parallel lines, except it's a plane. So plane in this case looks like a square. So you have AD, HE. This plane is parallel to BCGF. Now notice I correlated the proper letters on the square. That's what you want to do. You want to make sure the letters correlate. But those planes are parallel. Theorems 5-1 through 5-7 you can find on page 27 through 29. I would read them, but it'd be tough for you to hear them and just know them. So I would just look at them. They're very simple. I mean, one is all right angles are congruent. Well, duh, they're all 90 degrees. So very simple stuff. So you can look at page 27 and 28 and 29 and just take a peek at those theorems. I think that'll be better than me just reading them to you. You can look at them on your own. And then the only other thing really in this lesson to go over is postulate 10. And postulate 10 states, through a point not on a line, so we have a line and a point not on the line. Through a point not on a line, there exists exactly one line through the point that is parallel to the line. So call this line L. Well, through this point, there's only one way that you can draw another parallel line. You can't draw it any other direction. It has to be right here. So through that point, only one parallel line can be drawn to line L. And that's all postulate 10 states. I will say theorem 5-7, transitive property of parallel lines. Transitive property we've covered before. But that just states if two lines are parallel to the same line, then they're parallel to the other. So right here, we have AB, we have CD, and we have EF. Well, if I was to tell you that AB is parallel to CD, and that CD is parallel to EF, well then the transitive property simply states that all three of these lines are parallel. AB is parallel to CD, parallel to EF. And that is the transitive property of parallel lines in theorem 5-7. And that is all that there really is to lesson 5.